Located in the heart of the Arctic, Greenland is warming faster than the rest of the planet. That frozen territory is now undergoing profound change.
Le Groenland perd énormément de glace. J'aime bien dire qu'aujourd'hui, on a ouvert la porte du frigo parce que le réchauffement climatique entraîne des conséquences visibles dans ces régions. On le voit tout le temps, à la fin de l'été, les images satellites nous montrent que la banquise régresse en surface. Ce vélage intensif auquel on assiste est en train effectivement de perturber le climat.
Iceberg carving is one of the biggest uncertainties in future projections of how Greenland is going to change. So to better understand that process, we need high resolution measurements of tidewater glaciers and the icebergs that carve off the end of them. Satellite data is great to give us a large-scale picture of what's happening, and satellites have revolutionized our understanding of the Greenland ice sheet, there's no doubt about that. What satellites can't do is give us the detail that we need to understand processes in detail.
Ici, donc, on est au sud d'Ilulissat, à l'ouest du Groenland, côté du glacier le plus rapide au monde. Il faut s'imaginer qu'il parcourt une distance de presque 40 mètres chaque jour, donc ça fait 15 km chaque année. Pour mieux comprendre ses déplacements, son évolution, on s'apprête à prendre des images très précises avec des drones.
The fact that we have 3D measurements of icebergs in situ allows us to understand the rate at which it melts, but also the rate at which it disintegrates. This is really important because that meltwater released into the fjord changes the biogeochemistry, it changes the circulation. So then we want to understand if that has any impact on the marine ecosystems, but also the circulation, which may well impact the glacier of the fjord. We're trying to measure what's happening now, understand the processes so that we can input this into models to simulate what's going to happen in the future. Ekipsomia Glacier is located around 70 kilometers from Ilulissat. It's a tidewater glacier, so it's a tidewater glacier that's sensitive to changes in the ocean and the atmosphere. At Ekipsomia, we have drone data now where the drone has taken loads of pictures of the glacier, they've been stitched together and they've created a 3D model of the glacier surface. The glacier is really crevassed near the terminus, so those crevasses will end up being the lines of weakness where an iceberg falls off into the ocean. So what we're trying to do in this work is to understand the crevasse patterns to see if there are specific styles of carving that relate to this specific environmental condition that this glacier is in. And that is really where the drone data that we have is really helping us understand these processes.